Now, when we look at 1, the first thing we have to notice is they give us a what? An equation. Okay, now, is this a linear equation or a quadratic equation?
Linear.
Quadratic. How do we know that?
Because there's a t-square.
It's squared. Now, what I would do, first thing, is take this and put the equation in your calculator. So on y equals, I'm putting negative 12. I can't put a t, so I'm just going to put an x squared plus 36x. Now, okay, now, when you graph this, this is quadratic. You're not going to see that much of it. It starts somewhere up here, and it comes down here. We don't even know where the rest of it is. Okay? But let's just fill in the table. When I go to my table, okay, I do not have the halves. Okay? But I'll show you how we can fix that. Okay? When x is 0, y is what? 0. Now, just skip this for right now. When x is 1, y is what?
Negative 45. 24.
What's that?
24.
24. Okay. When x is 2, y is what? 24. And when x is 3, y is
Negative 48. No,
0.
0.
Now, when you're kicking a ball in the air, what's happening?
It goes up.
It goes up and then comes back down. Okay? Now, to fill in the 0.5, I'll show you one way you can do it. Now, you could put 0.5, you could substitute it in for x, or, look, okay, go to second calc on your calculator. You see where it says value? Y'all see where it says value? Okay, so just hit enter. Down at the bottom, you have a blinking and it says x equals. Put 0.5 and hit enter.
15.
So y is 15. Okay, do the same thing for 1.5. Second calc, value, 1.5, enter, 27. Okay, same thing for 2.5. Second calc, value, 2.5, 15. Okay, now, what's my x? What's my x? Okay, time. That's going to go down here. Okay, what's my y? Okay, which is what? What does the h represent?
Height.
Height. Okay, so now we're counting by what? Halves, right? So I'm going to start at 0. Then I'm going to skip 1 and put 1. Skip 1, put 2. Skip 1, put 3. Okay, or I could have even gone bigger than that. Now, my y has to be between 0 and what? 0 and what? What's my highest y? 27. So I really don't care what you really count by. Let's go 5, 10, 15, 20, 25, 30. Is that high enough?
Yes.
Okay, so now let's plot the points. 0, 0, 0.5, 15, 0.1, 24, 1.5, 27, 2, 24, 2.5, 15, and 3, 0. Okay, so you kick the ball, it goes up, and then gets to a certain point and comes back down. Now, what's a reasonable domain and range? Domain is all the what? Domain is all the exits.
Question.
What?
How can 1.5 is 27 into 24?
What's that? I'll look at that. I mean, because we put that in the calculator and that's what it told me. Did you not? Were you not following along when we did that?
Yeah.
I'll show you how again here in a minute. Okay? Now, so the x, what would be a reasonable amount? Is it reasonable to have negative time? No. So what would be a reasonable domain? Between 0 and what? 3. That's reasonable. Would it be reasonable to say between 0 and 5? Okay. So to write that, 0 is less than or equal to x, which is less than or equal to, you could put 3, you could put 5. That's all reasonable. Okay, the range. Is it reasonable to have negative height? No. So my range or my y's need to be between 0 and 27, or I'm just going to say 0 and 30 because that's where my graph went to. So reasonable range, my y is between 0 and 30. If I put 27, that's fine. Now, what's the vertex? Yeah, the highest point. What's the highest point? 1.5, 27. Now, you could have, found the maximum in your calculator and it'd probably tell you the same thing. Okay, the vertex, what does the vertex represent? The highest point. Okay, predict the time it takes the ball to hit the ground. When does the ball come back to the ground?
3 seconds.
3 seconds. Very good. Now, look at number 2. Okay, how does the graph of this differ from this? Okay, first of all, which graph, the 4x or the 1/4, is wider?
1/4.
1/4. This one's wider. Which one's higher on the graph? This one's +1, this one's -3. Which one's higher? Okay, this one's higher, right? Okay, let's look at 1, 2, and 3. It says the vertex of graph is 1 unit higher. Is it 1 unit higher than this one? How many units?
No.
How many units higher is it? 4. The vertex is 4 units higher.
Yes.
Yes. Okay, let's check the other one. The graph of 4x plus 1 is a vertical stretch. Is that a vertical stretch?
No. Yes.
Yes. So what would be the answer? 2 and 3. Very good.
But how do you
Because when that number's bigger, it's a stretch. When it's smaller, it's a compression. Yeah? What's that? What's your question?
No, I was
Okay. Trick question. Well, not really. Okay. What family of functions does this graph belong to? Well, which is the parent function, but what type of function is it? It's a quadratic. Okay, so which family? It is in the quadratic.
I would have gotten that wrong.
Okay, that's why we're talking about it. Okay, what's the vertex? Let's see if we can see from the graph. Okay, the vertex is at 0.
Two. X squared.
What's the vertex?
0.
What's the point? 0, 1.
And it's opening down.
Yeah. What's the y-intercept of the where does it cross the y-axis?
0, 2,
0,
1.
0, 1.
0, 1. What is the equation of the axis of symmetry?
Y
No, vertical line. The axis of symmetry is always x equals. Now, it goes through the vertex, so x equals what? 0. Okay, what are the zeros? That's one of those words that means the same thing as solution, x-intercept, zeros. Okay, so we're looking for the x-intercepts. Okay, so what are the zeros? What's this point?
Negative 1.
Negative 1, 0. Okay, and what's the other one?
0, 0.
No,
1.
1, 0. Now, domain and range. Okay, now, domain is the x's. Okay, we haven't talked about this specifically from this graph. But now, this quadratic function goes forever to the right and forever to the left. Okay, so how would I say the domain is all the numbers?
Infinity.
All real numbers, very good.
Where?
Now, does the y go forever?
No.
No, it's everything less than this point. What is that point? What's the y at that point? 1. So how would I say all the y's below 1? Y is less than or equal to what? 1. Okay, now, I will tell you this right now. All the domains of the quadratic function, unless they stop at a specific point, are going to be, it goes forever right, forever left. The domains usually are real numbers. Okay? The range, because it has a maximum or a minimum, so that will limit the graph. So the domain on A. What's the domain? The domain, all the x's. Goes forever right, forever left. So what's the domain? All real numbers. Okay? The range.
Mister, how did you get that part?
Because this graph just told you that these quadratics go forever to the right. Like if that this continues on forever and ever and ever, and it's getting further. Yes, x is the domain. It goes forever right, and it goes forever left. So how do I say that? All real numbers. Okay. Now the range, the y. Okay, it doesn't go on forever. It does. There's nothing below here, right? Okay, but it's forever up. Y is what?
Yes.
Y is greater than or equal to what?
1.
What's this?
Negative 2.
Negative 2. Now, what's the vertex? What's this point?
Negative 2.
Negative 2, negative 2. Is that a minimum or a maximum? Minimum. Because is that at the very bottom or the very top? Is the vertex at the very... If it's at the very bottom, it's a minimum. If it's at the very top, it's the highest it's going to be, so that's a maximum. Okay? Now, put the functions in order from widest to the most narrow. Which one is the widest? Which is the smallest number? 3/8. So y equals 3/8 x squared. Okay? The next widest. Y equals negative 1/2 x squared. Okay? Next in line would be what? Negative 3, good. Y equals negative 3 x squared, and then the most narrow one is y equals 5x squared. Very good. Write an equation of a function that is wider than any of them here. So we need a fraction that's smaller than this one.
1/8.
Okay? Y equals 1/8 x squared.
Mr. Britton,
That would be correct.
on that 5A, when the negative,
No, the negative just makes it open down. Because the negative in front just makes the graph open down. It's still wider or more narrow. Okay? Okay? Now, what type of graph is this?
Minimum.
No, what type of graph? It's a quadratic. What's the quadratic parent function?
X squared.
Y equals x squared. Very good. Okay, we have to pay attention here. It says write the equation of a quadratic function that is reflected across the x-axis. How do I reflect it across the x-axis or make it open down?
Negative.
Negative. X squared. Now, how do I move it 3 units up?
Plus 3.
Plus 3. Very good. There's my equation. Okay. Okay. Let's look at these. We just did a bunch of these. What's the difference? What's the change? What does the 1/3 do to the graph? It compresses or makes it
Wider.
wider,
wider.
wider,
Okay. What's the change here?
It went up two.
Up 2. Very good. Okay. Now, what does the negative do?
Wider.
What does the negative do?
Flex across there. That's not-
Reflects it
green,
or makes it open where? Okay, what does the 4 do?
Vertical stretch.
Vertical stretch.
What do you mean reflect?
Makes it open. That's why I put in parentheses. What did I put? Opens down and vertical stretch. What's another word? What does it do when I stretch something? It makes it
Thin.
Compress.
thinner. Or now, what was your question, Michaela? Yeah, compresses or makes it wider. Stretches or makes it thinner. What's that? Okay, makes it opens down. Okay. Okay. Now,